Slope fields are direction fields that give us the general shape of all the solutions of a differential equation. Now, it's quite straightforward to find a slope field. However, it can be quite tedious. Let's look at this differential equation here. Y prime is x minus y. And suppose I want to sketch the slope field at the point minus 1, 1. Then at the point minus 1, 1, I'm going to plug in x and y into y prime equal x minus y. So x is negative 1, y is plus 1. So we've got a negative there. So this is negative 2. So the slope at 1, negative 1, 1 is negative 2. So I come over here to negative 1, 1, and I put a short dash that is at about a slope of negative 2. Now let's look at the point 0, 1. At 0, 1, y prime equals what? Well, my slope is going to be x minus y, or negative 1. So I come over to the point 0, 1, and I make a short dash that has a slope of about negative 1. Now for my last point, 1, 1, I come in and I put in y prime is equal to x, which is 1, minus y, which is 1, which is 0. So I come over to 1, 1, and I put in a short dash that has a slope of 0. Now horizontal slopes, or when y prime is 0, is very important, and I want you to use that to try to match these up. If I look at this first differential equation, y prime equals x plus y, where are the slopes 0? Well, they're going to be 0 when y is equal to negative x. So do you see one of these where along the line y equals negative x, I have a series of 0 slopes? Well, of course, it's this number 2. So I would say that y prime equals x plus y has this as a slope field. Now let's look at y prime equal x. This has a 0 slope only where x equals 0. Which one of these has a slope field where x equals 0? And of course, the only one of these two that are left that has a slope of 0 when x is 0 is this number A. So this slope field is a slope field for y prime equal x. Now let's see, where does this one have a slope of 0? This one has a slope of 0 only where y is 0. Now, to sketch a slope field for a differential equation, the first thing you need to do is to make a chart of the slopes, and I have done that. For the differential equation, y prime equals 2x plus y, you want to pick regular intervals, usually around 0, 0, and as you can see, this can become quite cumbersome. To find each of these values, all right, you plug into the differential equation. Y prime is 2 times x is negative 2 plus y, which is negative 1. So this is negative 5. The next step, you make a short line at each point indicating the slope. So I would come over to 0, negative 1, and I would put in a short dash of negative 1 right here. And you do this for each one of the points. Now, when you get to points like 2, 1, where the slope is 5, they become almost vertical. And the third step is you start a curve at the initial point. So if I wanted it to pass through the point 1, 1, you come over to 1, 1, and put your dot. And then you start the curve at that point and you move to the right and you go parallel to the slopes, but you don't cross the slopes. And after you've gone right, then of course you go left. And you see you just keep going tangent, or excuse me, you go parallel to these little slope lines. Now, questions to ask yourself. Does y prime depend upon x? Does it depend upon y? The key ones are what happens when x and y are 0, and where is y prime equal to 0? This is probably one of the most important ones. You can also look at where y prime is equal to 1.